welcome to Cloud Tech 10 for the 16th of October 2017. I'm Mark and I'm going to tell you all the latest news about Microsoft Azure from the past week in 10 minutes or less. Azure Batch AI is a new service that helps you train and test deep learning and other AI or machine learning models using managed clusters of GPUs. Batch AI lets you provision clusters of GPUs on demand, install software in containers or via scripts, use automated scaling, utilize low priority virtual machines to reduce costs, and use shared storage volumes for training and output data. It works with any deep learning framework. There are recipes available in this GitHub repo to help you get up and running with a number of popular frameworks. Let's demonstrate how Batch AI works using this distributed Python sample. First, we're going to configure some default values to minimize repetition in the commands we're going to run. So we'll set our default location to East US and we'll define a default resource group to use. Next, we set some environment variables to hold details of the storage account and storage account keys that we're going to be using. Next, we download the data that will be used in our Batch AI job. I'm just copying the files from the GitHub repo to my local storage. When finished, we have 3 new files. Now let's create an Azure file share called Batch AI sample, and then within that share, let's create a directory named CNTK samples. Then we copy the files we're going to use for our Batch AI job up to our Azure file share using the AZ storage file upload command. If I go to the Azure portal at this point, I'll see that I now have the CNTK samples directory and those 3 files are now there. Let's create our Azure Batch AI cluster. In this example, I'm using the Azure CLI. The command starts AZ Batch AI cluster create. Next, we provide the name of our cluster. Then we select the image we want to use. In this case, an Ubuntu Data Science virtual machine. The size of the virtual machine is a standard NC6 class virtual machine. The min and max values are the same in this case, but specify the minimum and maximum number of nodes that this cluster can scale up and down to. Now we provide the name and share name for the Azure file share, and lastly, the username and path to the private key file that we'll be using to log into the servers. Once that's been submitted, it takes a few minutes for the cluster to be created. You can monitor progress through the Azure portal and watch until the nodes are ready to use. From the portal, you can see the details of the 2 nodes and the details of the Azure file share that we're using. Let's create our Azure Batch AI job. First, I'll download the job configuration file from the GitHub repo for this example. Once again, using the Azure CLI, we run AZ Batch AI, then job create, and we specify a name for the job, the cluster we're targeting, and the job.json file, which contains all of the job details. Once that's been submitted, we can again go to the Azure portal to monitor progress. We can see our 2 cluster nodes have now changed state from idle to running. If I click on jobs, I can see the job that we just submitted, and if I click on the job, I can see its current status. As the job progresses, I'm able to see information including output and error information. After a short while, the job is complete. I can check the standard out file to make sure that everything seemed to run okay. And if I go to the Azure file share, I can see the output of the job. A preview of the Visual Studio 2017 Service Fabric Tools 2.0 has been released. There are new .NET Core 2.0 project templates making it easy to create reliable services for stateless services, stateful services, and ASP.NET Core services. This update also adds support for containerizing .NET Framework projects and running them on Service Fabric. Any .NET Framework console application or ASP.NET application can be simply made into a containerized service with just a couple of clicks of the mouse. Durable functions are now available in public preview. Durable functions are an extension of Azure Functions and Azure Web Jobs that allow you to create long-running stateful workflows in code. Durable functions introduces the orchestrator function, which simplifies the coordination of other functions. For example, if you had a process that required multiple functions to execute, you would typically implement this with a set of functions and message queues, with each function passing data or state information to other functions via these queues. With durable functions, the orchestrator function can call each function in turn, passing data from the previous function's output. This enables many patterns, including function chaining as seen here. You can build a fan-in, fan-out function where multiple functions are executed in parallel, the results of which are combined on completion and then sent on to another function for final processing. Or you can write functions with durable timers that can wait for a specified period of time for another event, which could be useful in a scenario where human interaction is required, but you want to take a specific action if the human doesn't respond in time. Behind the scenes, durable functions makes use of Azure storage queues, tables, and blobs to persist the execution history state and to trigger function execution. But this is fully automated, so you do not need to concern yourself with the management of these resources. Durable functions works with application insights and can emit tracking data to monitor the behavior and progress of your functions. Right now, durable functions can be written in C#. Support for other languages is in the works. The public preview of Azure Database for PostgreSQL and MySQL has expanded and is now available in the Azure Canada Central, East Canada, and Brazil South regions. A public preview of snapshots in Azure file shares is now available. This enables you to store a read-only version of a file share, which could later be used to access older versions of files or folders. In Windows, you can use the previous versions feature to make use of Azure file share snapshots. Here, I have a Windows computer with an Azure file share. I've got a newsletter in here that I want to send, but it seems to have disappeared. Let's go to previous versions. In here, I can see that there are currently 2 snapshots available. I'm pretty sure that the document was there yesterday, so let's take a look at that one. I can see this was created yesterday evening, and here's my newsletter. I can now copy this document and paste it back into my file share, and there you go. My file has been restored from yesterday's snapshot. I can also manage snapshots through the Azure portal. I choose files and then the file share that I want to work with. From this snapshot button, I can create a new snapshot instantly, or I can view all of my snapshots and browse the files and folders within each one. The Azure Management Libraries for .NET have been updated to version 1.3 and now include support for virtual network peering, site-to-site connections for virtual private networks, and the ability to create Azure container instances. Plus, this update includes a preview of availability zone support, allowing you to create virtual machines and virtual machine scale sets in availability zones.